Hello, I was watching some FTFE debates over the past little while, and Craig did bring up the Vendée Globe race as proof that the Earth is a globe. And I thought I would take a look at it myself as well to see what I could find and what I could come up with on it. So, if you're not familiar, the Vendée Globe is a boat race that starts off in France. It goes down the Atlantic, then it goes around South Africa, then it keeps going around south of Australia, south of New Zealand, then it comes back up around south of South America, then goes back up the Atlantic and then back to France. It's a race where it's just one person on their sailboat. As you can see, it happens every few years, 2000, 2001, 2004, 2005. So it seems to be every 4 years. So the next one should be 2024. On the VendéGlobe.org website, there is a page called Ranking, and on that you can choose 12 p.m., 2 p.m., 3 p.m., 7 p.m., 9 p.m., 4 a.m., 8 a.m., 11 a.m. So it seems to be roughly every so often from the start of the race to the end of the race. So this page is at the start. Each participant has a geo-coordinate and a distance to finish. It also gives their speed. And so if I go ahead a couple of days into the race, you can see that the geo-coordinates have been reported. It also gives their heading, their speed, and their velocity mode on course speed as well. So it took a little bit of doing, not too much, but I wrote a script that got a copy of every single one of these pages. Unfortunately, they did not provide a nice, easy download the entire course data in an Excel spreadsheet, so I had to recreate it myself. I got a copy of every web page, and then I wrote a script to parse it out and to create a CSV file that I then imported into Google Sheets with the idea that for every participant, I would end up taking all of their data and copying it to a separate tab. I created a template that I would then copy over for somebody else, and that the template would have all of the necessary calculations required. So if I go to the end of the race, here we can see that out of 33 people, 25 completed the race and the rest retired from the race before they completed. And so I started off with the guy who won and put all of his race data in this tab of this spreadsheet. And so the data that was provided included things like knots, kph, that velocity, something or other, that VMC thing, heading, latitude, longitude, nautical miles to finish, so on and so forth. And so I created a chart with the kilometers per hour that were provided here. And I was able to infer the kilometers traveled by using the reported time in UTC. So basically what I did was I converted date and time into Unix time. Unix time is the number of seconds that have elapsed since January 1st of 1970. So I'm able to subtract one date from the other and to determine the number of seconds that have elapsed. So given the reported kilometers per hour and the number of seconds since the two, I was able to infer a number of kilometers traveled in that time span that they provided. There's that timestamp, by the way. And in this section, what I did was I took the geo-coordinates that they provided and compared it to the geo-coordinates from the previous time. From there, I was able to use the Haversine formula that is intended to calculate the distance along the surface of a sphere based on two sets of coordinates. I was able to recalculate the distance in kilometers and the speed in kilometers per hour. I calculated the difference in kilometers per hour by subtracting my kph from the kph that they provided. So this graph was generated by my calculations using the Haversine formula to calculate the distance and the speed based on the times reported, which would be this time and is the time reported in UTC. The distance being the two lat-long coordinates from this time compared to the previous time. And so as you can see, the kilometers per hour is a relatively constant and relatively straight line. And there are going to be some dips and some peaks as time goes on, but it's relatively straight. I've also made videos in the past that show how I go about calculating the distance if the Earth was flat. In fact, I've already made some spreadsheets available that show how I make those calculations, but very quickly, here it is again. And as one would expect, if the Earth was flat, the distance between two longitude points along any latitude point would have to increase the farther away from the North Pole you would get. Again, here I calculate the kilometers per hour that should be expected if the Earth was flat, along with a difference in kilometers per hour between what they provided and what I calculated if the Earth was flat. And here we see that there's a very serious problem, because not only are there two different levels of kilometers between each reporting, but the reported speed is also not a nice straight flat line like you would expect like this. But I wasn't quite happy with those graphs, so I decided to create a few more. In this one, for the globe, the blue line that you see here is the recomputed kilometers per hour based on the difference between this reporting time and the previous reporting time. The yellow line that you see here is the difference between my recomputed kph and their provided kph. I also included the latitude, which is the red line, and the longitude, which is the green line. And I also added a purple line that you see here, which is kind of like an average or a trend line. So for the most part, the difference in kilometers per hour from my Haversine-based globe Earth distance and speed is very close to zero for the entire duration of the race. If we contrast that, however, to the flat Earth, we see that there is something completely different and it doesn't fit at all. So here again, we see there are two different average speeds. Here there's one reasonable speed of around 25 to 30 kph, and then it jumps up to an average of about 100. In some cases, it peaks to 182.9, let's say 183 kph before coming back down. The difference between my calculated flat Earth kph and the kph that they provided in this case jumps up dramatically. But what's even more telling is that the farther south they went, the greater the difference. And as they were traveling more east, that also occurred as well. So I added an extra mode to my skywatching app that's now turned into its own special kind of monster. I can now provide it different routes, and it will plot it on a globe or on the flat Earth map or whatever. So here we can see that the race started off in France, then it went down south, then they started going east like this, and as they kept going around, they eventually went around South America, and then they came back up the Atlantic like that. If we use globe Earth math and recreate what was provided on the Vendée Globe website, I noticed that everything matches. What does it look like if the Earth was flat and it was really shaped like the AE map? Then here they would start off in France, and then they would go south, and then they would quickly have to pick up speed to go all the way around, circling the Earth, hugging the flat Earth precious, the ice ring, the ice wall, before they come back up the Atlantic. And just for reference, That's the path that every one of them took. So if the Earth was flat, like you see here, and they were using the prevailing winds on a sailboat, and they could only achieve a certain speed going north-south like this until they reach 50 degrees south or thereabouts, then as they start going eastwards like this, they would have to go much, much faster in order to maintain the same relative percentage of the entire distance traveled. And so that's what this graph represents. As you can see, the boat would have to be going nearly 200 kilometers per hour. I'll just say that again. These sailboats would have to go nearly 200 kilometers per hour if the Earth was flat. Of course, if the Earth was a globe, it really wouldn't be that big of a deal because they would only have to maintain around 30 to 40 kilometers per hour, which is far more reasonable for a sailboat like this. So either NASA has infiltrated every last facet of our modern society and have faked the data that has been provided on websites like the Vendée Globe, or the Earth is a globe and flat earthers are just making everything up. That's going to be it for now. Thank you for watching. If you like the video, I would appreciate the thumbs up, the subscribe, the comment below, all that other good stuff. And I'm going to see you again in another video soon enough. Bye for now.